Welcome to the third video for Chapter 5. This is starting with 5.5, which is using similarity in problems. So, in this section, it just really goes over how to use the different similarities we learned about in problems, and it's just a bunch of practice with problems that you might see or might be similar to those types of problems. But in this section, something I want to go over is sort of emphasized in problem 5.15. So I'm going to go over that now. So in problem 15, basically you're given that triangle ABC is similar to triangle XYZ here. So because you're also given AB over XY is equal to 4 and that the area of triangle ABC is equal to 64. Now what it wants you to do is it wants you to find the area of triangle XYZ right here. So the way you're going to go about this is fairly simple. So first, you want to find what the ratio of their areas is. So the way you do that is you think, okay, so let's start with their altitudes. The altitude of triangle ABC is CP here. The altitude of triangle XYZ is ZV here. So the way you can do this is you can just think, okay, 4 to 1, because if you think about it, the ratio is just 4 to 1 right here, 4 over 1. So if you have to prove it, and if you want to see a proof, this is how you do it. The way you think about it is this angle A right here is equal to angle X because we have this right here, that triangle ABC is similar to triangle XYZ, so their angles, the corresponding angles are equal. So to start off, we have angle A is equal to angle X. Then because this is a 90-degree angle right here, this means this is also a 90-degree angle because it needs to equal 180, so 90 plus 90 is 180. And it's the same over here, this right here is a 90-degree angle. So you have two angles, two corresponding angles, which are equal. So just by doing that, you prove triangle APC is similar to triangle XVZ by angle similarity. So with that, you can say, okay, CP over ZV is equal to AC over XZ, because it's part of the same triangle here, so the ratio of these sides over each other should be the same. And since AC over XZ is equal to 4 over 1, the ratio of CP over ZV is equal to 4 over 1. So the ratio of their altitudes is 4 to 1. This is 4 and this is 1. So now that we have the altitudes, we need to find the ratio of the areas. So A, B, C, the area of ABC over the area of X, Y, Z. So this is equal to base times height over 2 for any triangle. That's the area, base times height over 2. So for AB, triangle ABC, it's going to be AB, which is the base, times the height, which is CP, over 2. That's all over 2. And that's for XYZ, it's just going to be XY, which is the base, which is matching up with AB, over ZV over 2. Now, the 2's cancel out here, so you just really have AB is equal to AB over XY times CP over ZV. So because we already figured out the ratio of CP over ZV is 4 over 1, what we have here is 4 over 1 times 4 over 1. So it's going to be equal to 4 over 1 squared, which is just equal to 4 squared, which is equal to 16. So now that we have that this is equal to the ratio of the ratio of the area of ABC over XYZ is equal to 16, we can say, okay, the area of x, y, z is equal to ABC divided by 16. And so because we were given the area of ABC, which is 64, this is just equal to 64 over 16, which is equal to 4. So that's the area of triangle XYZ. And so this brings up an important point. So if two triangles are similar, such that the larger triangle, so we have the ratio 4 to 1 here. Let's say this is kx. Over here it's just going to be x. So this triangle is k times the size of this triangle right here. Then if you have this, so it's times x times k, and so it's way bigger than this. So for this it was 4. So k is equal to 4, and x is equal to just 1 over here, so that's how you get that ratio. So what's important about this k is the area of the larger triangle here. It's going to be k squared times the area of the smaller triangle. So the area of small triangle. So if we go back to this problem here and we think about it, k squared is 16 because 4 squared is 16. And the area of the smaller triangle we figure out is 4. So 16 times 4, it's equal to 64. So when you're solving a problem, this is an important rule to know. So basically, the bigger triangle is k squared times the area of the smaller triangle. Now I've moved on to section 5.6 here, and 5.6 is on construction, and it's talking about angles and parallels. So what's really important about this section is that they want you to think similar triangles when you see parallel lines and everything. If they ask you to prove parallel lines, they want you to show that triangles are similar and then use angles and everything. And by using angles, you can figure out that if these two lines are parallel, then you can have similar triangles and all of that. So I'm going to go over a problem in sections 5.6, and so this is problem 5.21. And so problem 5.21 says, draw a segment AB. In this problem, we learn how to divide AB into 3 equal pieces. So what your book does is a little different. So what they do is they just have AB here, and they have X, Y, and then they have another line, AR, with P and Q in there. So they simplify it down and say, okay, so AP, they make AR, so it's divided up into 3 equal pieces, AP, QP, and QR. And these 3 we know are equal because all they did was they took AP and then they took 3 of them and went 1, 2, and then so they have 3. So this is the same length as this and this then. So basically AP is equal to PQ, which is equal to QR, which is equal to AR over 3. Now, the way they're going to divide up this AB into 3 equal parts here is using parallel lines. So they draw parallel lines down from R to B, from Q to Y, from P to X, and then what they do is they say, okay, let's prove similar triangles. So they use the angles and parallel lines to prove similar triangles. So they know this angle is equal to this angle, which is equal to this angle. Then they also know that this angle here is equal to this angle here, which is equal to this angle here. So by using a similarity, they can prove these triangles equal. So now that you have these triangles and you have them divided up, you can say, okay, now that these triangles are similar and you have the sides here, AX over AB is equal to AP over AR. Because if you look at the triangle here, you have triangle APX. And you've proven with a similarity that this little triangle here is similar to this whole big triangle here by using the angles and parallel lines. And so now what you do is you write it out like this. So AX, this part right here to this part right here, should be the same ratio as this part right here to this part right here. And since we already know the ratio of AP to AR, because AR is just 3 times AP, the ratio is equal to 1 over 3. So then we get that AX over AB is equal to 1 over 3. And you can do the same thing like this. So you do it, if you do triangle AQY, then you see that there's 2 of AP in here, because you just take AP and then double it, which is AQ. So if you have AQ over AR, it's equal to 2 over 3, which is equal to AY over AB. And then from this you can go AY is equal to 2AB over 3. Now if you just subtract AX out of that, you get, okay, so just minus 1/3 of AB, and then you get XY is equal to AX. So this is equal to this, and this is right there. And if you just figure it out, this has to be equal then, because if this is 2/3, the only thing's left that's 1/3, which is equal to AX. So that's how you can prove that you split it into 3 different parts by using similar triangles. And that's it for chapter 5. I hope to see you guys in the next video.